Hello everyone, namaste. Welcome back to my channel AcademicTuber. Today we are going to discuss Unit 8 from Grade 10 Science, that is pressure. Before that, if you are new to this channel, please subscribe the channel and for more updates hit the bell icon. If you want more videos related to this, please like and do share this video among your friends, and also don't forget to give your valuable response in comment section. Pressure. Pressure can be defined as the force acting perpendicularly on unit area. Mathematically, pressure equals to force by area. The SI unit of pressure is Newton per meter square or Pascal. It is a scalar quantity because pressure is always normal to surface area, that is, it does not have direction. 1 Pascal pressure. We know that the formula to calculate pressure equals to force by area. If F equals to 1 Newton and area equals to 1 meter square, then pressure is equals to 1 Pascal. That is, 1 Pascal is defined as the pressure created when 1 Newton force acts on the area of 1 meter square. Pascal's law. French scientist Blaise Pascal propounded a law related to liquid pressure in 1647 AD, which is popularly known as Pascal's law. This is one of the basic principles of hydrostatics. Hydrostatics is that branch of physics which deals with the property of fluids at rest. Pascal's law states that the pressure applied at a place on a liquid contained in a closed container transmits equally and perpendicularly in all directions. Pascal's law, it is also called the principle of transmission of liquid pressure. A number of devices such as hydraulic press, hydraulic garage lift, etc. work on the principle of Pascal's law. Pascal's law is also applicable for the gases. Experimental verification of Pascal's law. Materials required: a spherical container fitted with 4 pistons of equal cross-section area and water, as shown in the figure. 4 pistons of equal cross-section area: piston A, piston B, piston C, and piston D. Procedure: we should take across a spherical container fitted with 4 pistons A, B, C, and D of equal cross sections. Then we should fill the container with water and push the piston A inward with a force as shown in the figure. The arrow represents the direction of force. Observation: all the other pistons are pushed outwards when the piston A is pushed inward. The outward distance moved by all the pistons will be equal to each other as well as to the inward distance moved by the piston A. Conclusion: pressure given to the water of the container through piston A is transmitted to all directions. So all the other pistons moved outward with equal distance. It proves that the liquid pressure transmits equally in all directions when pressure is applied to a liquid kept in a closed container. Application of Pascal's law. Pascal's law can be used in hydraulic lift, hydraulic brake, hydraulic press, hydraulic cranes, etc. Principle of hydraulic machine. It states that when a small force is applied on the small piston, a large force is developed on the bigger piston. This is because no liquid can be compressed and pressure applied on an enclosed liquid is transmitted equally to each part as per the Pascal's law. To prove that hydraulic machine is force multiplier. So here is a diagram showing a hydraulic lift. Let us consider a hydraulic lift having 2 pistons of cross-section area A1 and A2 as shown in the figure. When an effort F1 is applied to the small piston, a force F2 develops on the larger piston. As per the Pascal's law, pressure exerted by small piston P1 equals to pressure created on larger piston P2. That is, F1 by A1 equals to F2 by A2. Okay, while doing cross multiplication, we get F1 A2 equals to F2 A1. Since A2 is always greater than A1, F2 is greater than F1. Hence, we can conclude that hydraulic machine it is a force multiplier. Hydraulic garage lift. Hydraulic garage lift is a device which is used to lift light vehicles in a garage during their maintenance or service. Construction. It consists of three metallic cylinders of different diameters. They are connected together by a horizontal connecting tube and the whole system is filled with water. The piston of a small cylinder is fitted with a lever, whereas the piston of large cylinder is fitted with a platform to rest vehicles for maintenance. The reservoir and the larger cylinder are also connected by another tube which is provided with a stopper, yes, as shown in the figure. The horizontal connecting tube is provided with valves X and Y. Here is a diagram showing the hydraulic garage lift. Working mechanism. When effort is applied to the small piston with the help of lever, the valve X gets closed and valve Y opens. The pressure exerted to the liquid by the small piston is transmitted to the larger piston, and the effort is magnified by the larger piston due to its large area. Thus, vehicles can be lifted. When a stopper is opened, the water flows from large cylinder to the reservoir, thereby bringing the vehicles to the previous position. Next one is hydraulic brake. Hydraulic brake are the brake which works on the principle of Pascal's law. They are mostly used in heavy vehicles. Construction of hydraulic brake. It contains a tube containing brake oil. Its one end is connected to a master cylinder and another end with a slave cylinder. A piston connected to pedal is fitted to the master cylinder. The slave cylinder is fitted with two pistons each connected to the brake shoe. The pistons of slave cylinders have larger diameters than that of the master cylinder as shown in the figure. So here is a diagram showing a hydraulic brake. Working mechanism. When the brake pedal is pressed, the piston of the master cylinder exerts pressure to the brake oil. This pressure is transmitted to the piston of slave cylinder. The force will be multiplied by many times due to large area of these pistons. The large force hence presses the brake shoe, which in turn presses the rim of vehicles. Thus, the vehicle stops when brake pedal is pressed. So here is one question related with to hydraulic machine. By which two properties of liquid it is used in hydraulic machine? So liquid it is used in hydraulic machine because of following two properties. Liquid transmit pressure perpendicularly in all direction, and next one, liquid it cannot be compressed. Upthrust. When an object is placed in a liquid, the liquid exerts force to the object in upward direction. For example, when you dip a cork inside the water and release, it rises up to the surface immediately as if the water is pushing it upward forcefully. Similarly, when you pull a bucket of water from a well, it is easier when it is inside the water. The bucket becomes heavier as soon as it comes out of water. Boats, ship, etc. floats on water. These all are due to upward force exerted by the water surface called upthrust. The resultant force, or we can say the resultant thrust, with which a liquid pushes an object in inward direction when it is kept in the liquid is upthrust. It is also called buoyant force and its SI unit is Newton. Archimedes principle. When an object is kept in a liquid, its weight decreases. Greek scientist Archimedes carried out an experiment to find out the magnitude by which weight is decreased. The result obtained from the experiment was incorporated in a principle named Archimedes principle. Archimedes' principle states that when a body is wholly or partially immersed in a liquid, the upthrust experienced by it is equal to the weight of the liquid displaced. This principle is also applied for gas. Theoretical verification of Archimedes' principle. So let us consider a cylindrical object of height h and cross-section area A be immersed in a liquid of density d as shown in the figure. The horizontal thrust given by the liquid to the cylinder from various sides balance each other because they are equal in magnitude due to the same depth, but they are opposite in direction. The arrowhead in the diagram shows the direction. Let the depth of the upper and the lower surface of the cylinders are h1 and h2 respectively. The liquid pressure acting on the upper surface of upper face of body P1 equals to D into G into H1. Similarly, the liquid pressure acting on the lower face of the body P2 equals to D into G into H2. Similarly, the force acting on the upper face is given by the formula F1 equals to P1 into A. Since we know that pressure equals to force by area, doing cross multiplication we get a force equals to pressure into area. Similarly, the force acting on the lower face, that is F2 equals to pressure 2 into A. Since S2 always greater than S1, the force on the lower face F2 is greater than the force on the upper face F1. So the net resultant thrust on the cylinder is given by F equals to F2 minus F1, which is equals to P2A minus P1A, so which is equals to DGS2A minus DGS1A. Now we are going to take a DGA common. So DGA we are going to take common S2 minus S1. Let S2 minus S1 equals to H, which is the thickness of the rectangular body. From equation 5 we have force equals to D into G into A into H, and we know the formula of volume is area into height. So in place of A into H we are going to write here V. So F equals to D into G into V, which is the volume. V is the volume of body, which is equals to the volume of liquid displaced. Equation 6 is the mathematical form of Archimedes principle. Here the quantity V into D into G represents the weight of the liquid displaced. V into G, D into G equals to M into G equals to weight. So therefore upthrust equals to weight of liquid displaced. Thus Archimedes principle is verified, and the Archimedes principle it is used to operate hot air balloons, submarines, hydrometers, sailing of ship, etc. Factors affecting upthrust. Volume of submerged part of the body. Upthrust it is directly proportional to the volume of the body submerged in a liquid, that is volume increases, upthrust increases, and vice versa. Next one is density of liquid. Upthrust is directly proportional to the density of liquid, that is density increases, upthrust increases, and vice versa. Acceleration due to gravity. Upthrust is directly proportional to the acceleration due to gravity, that is acceleration due to gravity increases, upthrust increases, and vice versa. Similarly, temperature of liquid. Upthrust is inversely proportional to the temperature of liquid, that is temperature increases, upthrust decreases, and vice versa. So here I am going to correct the spelling of vice in vice versa. V-I-C-E, vice. Application of buoyancy. Buoyancy upthrust make it possible for swimmer, fishes, ship, and iceberg to stay afloat. Some applications of buoyancy are given in the points below. First one is hot air balloon. The atmosphere is filled with air that exerts buoyant force on any object. A hot air balloon rises and floats due to the buoyant force. Next one is ship. The floating mechanism of ship and boats is based on the product of buoyant force. The immersed part of a ship and a boat displaces water equal to the volume of the immersed part. When the weight of the displaced liquid becomes equal to the weight of the ship or boat, it flows. Because of this reason, when a ship or boat is loaded in with cargo, its hull sinks more and more. Next one, fish. A certain group of fishes uses Archimedes principle to go up and down the water. To go up to the surface, the fish will fill its swim bladder air sacs with gases. The gases diffuse from their own body to the bladder and thus make the body lighter. This enables the fish to go up. Swimming. Swimming activity of humans or fish and other animals are also the product of buoyant force exerted on their body. To meet the buoyant force equal to the weight of their body, different animals do different action. Some of them move their hands and legs to displace enough water, and in this situation the immersed part of the body becomes able to displace water equal to the body weight of that organism to be floated. Next one is hydrometer. Hydrometer, it is a device which is used for measuring the relative density or specific gravity of liquid directly. It consists of a glass and has a bulb at its one end. The bulb is partially filled with a lead source as it stays vertically in liquid and the source are wax over it. It is a wide evacuated body and a narrow stem. On the stem, it has a scale with marks. When it is kept in any liquid, it displaces the liquid equal to its weight that creates buoyant force on it. Hydrometer remains vertical in the liquid due to its heavy bulb. In this condition, the reading of the density is given by the scale on the stem which remain at the upper level of the liquid. The hydrometer used to measure the density of liquid is called lactometer. Lactometer, it is a specially designed hydrometer which is used for testing the purity of milk. So here is one question related with that. It is easier to pull a bucket of water when it is inside water. Why? When a bucket of water is inside the water, it experiences more upthrust given by water. But when it is pulled out of water, the upthrust given by air is less. Thus, a bucket of water is lighter when it is inside the water. Next question. A ship coming from sea enters the river. Will its hull sink sink more or less in river water? The hull of ship sinks more in the river water because the upthrust given by river water is less than the upthrust given by sea water. Next one is density. Density is defined as mass per unit volume and its unit is SI unit is kg per meter cube. Mathematically, density equals to mass by volume. Relative density, it is the ratio of density of substance to the density of water at 4 degrees Celsius, and the another term for relative density is specific gravity, and it has no unit as it is the ratio of same physical quantities. Mathematically, relative density equals to density of substance by density of water at 4 degrees Celsius. Law of flotation. When a body is kept in a liquid, two types of force exist here. The weight of the body will act vertically downward. The upthrust on the body acts vertically upwards. Depending upon the magnitude of these forces, following three conditions may exist. And the condition, it is represented by the figure A, figure B and figure C. First one, condition 1, which is shown in figure A. When the weight of body is greater than the upthrust, the resultant force is vertically downward. Then the body sinks as shown in the figure A. This condition exists when density of a body is greater than the density of the liquid. Next one, condition 2, which was shown in figure B. When the weight of body is equal to the upthrust acting on it, the resultant force acting on the body is 0. Then the body flows just in the liquid as shown in the figure B. So here we can see in figure B, the body just float in the liquid. This condition exists when density of body is equal to the density of liquid. And finally here it comes the condition 3. When the weight of the body is less than the upthrust acting on it, the resultant force acting on the body is directed upward. As a result, the body flows on it with some pass in the air and the little part of water as shown in the figure C. In this case, the weight of the body is equal to the weight of the liquid displaced by the immersed part of the body. This condition exists when density of body is less than the density of liquid. Law of flotation states that an object that floats on the liquid medium displaces the liquid equal to its weight. That is, weight of floating body W1 equals to weight of displaced fluid or liquid W2. Difference between Archimedes principle and law of flotation. Archimedes principle. When an object is immersed fully or partially in a liquid, it experiences an upthrust which is equal to weight of liquid displaced by it. Whereas in law of flotation, an object that floats on liquid displaces the liquid equal to its weight. Archimedes principle. It is equally applicable for floating as well as sinking body. Law of flotation, it is applicable for the floating object only. Archimedes principle can be applied to the working of submarine, ship, hydrometer, etc. Whereas law of flotation cannot be applied to the working of submarines because it floats as well as sink in water. Atmospheric pressure. The pressure of air that acts upon the unit area on the surface of the earth is called atmospheric pressure. The atmospheric pressure at the sea level is 10 to the power 5 Newton per meter square or 760 millimeter of hydrogen mercury or 1 atmosphere. This pressure is known as the standard atmospheric pressure. There are different other units for the measurement of pressure. 1 atmospheric pressure equals to 760 mm of mercury. 1 atmospheric pressure is equals to 760 torr. 1 atmospheric pressure equals to 1,01,325 Pascal. 1 atmospheric pressure equals to 1.01 into 10 to the power 5 Newton per meter square. 1 atmospheric pressure equals to 1.01325 bar. The pressure is 1000 times greater at the depth of 10,000 meter from the surface. Uses of atmospheric pressure: to fill ink in a fountain pen, to fill medicine in syringes, to fill air in a bicycle tube or tube of vehicles, to lift water by using water pump, to soak juice or soft drinks through a straw, etc. So here is one question. An egg sinks in pure water but floats on salt water. Why? Density of salt solution is more than that of pure water. Due to this, the salt solution gives more upthrust to the egg to make it float, but the upthrust given by pure water is not sufficient to make the egg float. Next one, a piece of iron sinks in water, but the ship made of iron floats on water. Why? The density of iron is more than that of water. Therefore, the amount of water displaced by the piece of iron is less than its weight, and the upthrust applied by the water is not sufficient to make the iron piece float. But a ship made of iron is hollow and contains air, so its average density is less than that of water. Therefore, it displaces water equal to its weight, making the ship float. By this, we have completed nodes of the unit pressure. I hope this video was useful to you. If you like this video, please share with your friends and don't forget to subscribe. If you have any queries, drop the comment in the comment section. See you on the next video. Thank you.